Continuing with the anterior pituitary hormones, we have adrenocorticotropic hormone. Now, adrenocorticotropic hormone is secreted by the corticotrophs of the anterior pituitary. That means these cells are producing adrenocorticotropic hormone, which then can be stored in the anterior pituitary and released by the anterior pituitary. The purpose, the function here, while it's released into the blood, you only have receptors for ACTH, adrenocorticotropic hormone, on the adrenal cortex. So that means only the adrenal cortex is stimulated by this hormone. So sure, you can find it in your head, in your feet, in your hands. It's not doing anything there. This hormone only has receptors on the adrenal cortex, and that's it. So it's stimulating the adrenal cortex to release the corticosteroids. Now, we'll get to the adrenal glands a little bit later and what those are and things, but just know that ACTH, adrenocorticotropic hormone, stimulates only the adrenal cortex. Now, ACTH does have regulation, just like the previous ones, growth hormone, thyroid-stimulating hormone. Adrenocorticotropic hormone is regulated by the hypothalamus. You have CRH, which is corticotropin-releasing hormone. Now, this corticotropin-releasing hormone will be produced up in the hypothalamus, sent via the blood down into the anterior pituitary. In the anterior pituitary, it then stimulates production of ACTH. Then it will be released and heading down to the adrenal cortex. But there are different factors, internal and external, that will have an impact on CRH. So the corticotropin-releasing hormone can be impacted by fever, so if someone's sick, be impacted by a hypoglycemic state, low blood sugar, can be impacted by various stressors in the body. Now, if you're thinking, hold on, I've got some stress, yeah, everybody's got stress. Your body actually needs a certain level of stress. The trick is to have the appropriate level and not too much. Because as stress levels increase, it'll have an impact on ACTH levels in your body. So again, internal as well as external factors can impact the corticotropin-releasing hormone. Gonadotropins. Now, gonadotropins is actually a group. It's not one single hormone. The gonadotropins are luteinizing hormone, LH, and follicle-stimulating hormone, FSH. Those two hormones together make up the group of gonadotropins. So both follicle-stimulating hormone and luteinizing hormone are produced and secreted by the gonadotrophs. The gonadotrophs are the cells found in the anterior pituitary. They'll produce both of these hormones. So again, anterior pituitary will have production of both FSH and LH from these gonadotrophs. Now, FSH, follicle-stimulating hormone, like the name says, it stimulates the follicles, egg and sperm. So FSH, or follicle-stimulating hormone, is going to help with production of egg and sperm. Now, LH, or luteinizing hormone, is helping with the gonadal hormones. Think testosterone, estrogen, progesterone. So both are important as far as reproductive processes, but they both have their own individual functions. FSH, with the follicle-stimulating hormone, deals with the actual egg and sperm, while luteinizing hormone deals more with the hormones of the gonads. So how do you regulate both of these? You regulate them the same way we've been doing it the previous ones. You have control out of the hypothalamus. The hypothalamus is going to have this gonadotropin-releasing hormone, GnRH. Gonadotropin-releasing hormone is produced in the hypothalamus, sent down to the anterior pituitary to stimulate FSH and LH production, which then can be secreted and head out in the body. Now, if you notice, put up here, that is after puberty and during puberty. That's because there's a little different controlling mechanism pre-puberty in individuals. But this is a negative feedback cycle, which means that if FSH levels rise, LH levels rise, it tells this to say, hey, cut back on gonadotropin releasing hormone. You don't need it, because you're always trying to maintain a homeostatic level. Too much or too little can throw the whole system out of balance. Prolactin, PRL. Now, prolactin is secreted by the lactotrophs in the anterior pituitary. So again, just like all the rest, there's a specialized cell in the anterior pituitary producing this hormone. Now, one of the main functions is milk production from prolactin. So milk production in the female after giving birth. So how do you regulate? Just like all the rest. We have this prolactin inhibiting hormone, PIH. The prolactin inhibiting hormone will stop the production of prolactin, basically. Your prolactin inhibiting hormone basically is dopamine. So you have this controlling mechanism again to try and prevent or inhibit production if it's not necessary. So towards the end of pregnancy, the blood levels are starting to rise though. And eventually, once the infant is born and suckling occurs for breastfeeding, you're going to have this prolactin releasing factor. Now, the prolactin releasing factor is in response to the suckling action on the nipple of the female. Now, while this could be produced, it doesn't guarantee production of milk. That is something that is a very personal matter, and some females can, some females can't. Depends on the way the body works. But either way, this prolactin releasing factor is what will actually promote the continuation of milk production throughout the breastfeeding cycle. So it's a self-perpetuating cycle where you have the suckling creating a positive feedback to create more milk for the future use. All right, we'll refresh a review of all the hormones we're looking at from posterior and anterior pituitaries. In the posterior pituitary, we had ADH and oxytocin. ADH and oxytocin are produced back in the hypothalamus. They're only stored and then secreted from the posterior pituitary. For the anterior pituitary, we have a whole list of hormones here. We had luteinizing hormone and follicle-stimulating hormone, both gonadotropins produced out of the anterior pituitary. We then have thyroid-stimulating hormone. We have prolactin. We have growth hormone. We have adrenocorticotropic hormone. So all of those are produced, stored, and secreted out of the anterior pituitary. But in between the anterior and posterior pituitaries is this kind of pars intermediary. So it's the intermediary pituitary. It actually has a function itself. It's producing melanocyte-stimulating hormone. Now, melanocyte-stimulating hormone, like it sounds like, is going to stimulate melanin. So what happens here is you have this pro-opiomelanocortin. Pro-opiomelanocortin, or POMC is a lot easier, is a precursor protein. That then is going to stimulate melanin. So melanin is being produced because of this melanocyte-stimulating hormone in the pars intermediary, or the intermediary pituitary. So we focused on the posterior and anterior pituitary, but that section right in the middle also has its own functionality. Has this melanocyte-stimulating hormone. So a whole bunch of hormones just from the pituitary gland itself. Posterior pituitary stores and secretes, does not produce. Anterior pituitary went through 6 main ones that it produces, stores, and secretes. And then right between the two, that intermediate pituitary has one that's being produced and secreting as well. So the pituitary gland, kind of important, but we've got a lot of other glands that also are secreting hormones as well.